Hello, everyone. This is a video demo describing lab number 7, the digital clock, the clock design, where we're going to be designing a clock with minutes, seconds, and part of seconds. So let's talk a little bit about how we are going to be designing this. So number one, you're going to be copying from your book the code for the clock divider. And what does that code do? That code will reduce the frequency of your original clock. So for your FPGA, your clock is 50 megahertz, okay? And that is so fast, like my eyes, we can't see that change. So we need to slow it down a little bit. And I'm asking here for the, to slow it down to 1/100 second, okay, clock. Now this is your T, okay, so that's your period should be 101 second. In other words, your frequency is just gonna be 1/the T, so I'm asking for a frequency of 100 hertz, okay? So now what we wanna do is we want to move from 50 megahertz, okay? So let's say that this is your clock. Let me just go here. So as you see, it's very, so it's so fast, okay? And now what I want to do is I want to slow it down. So I'm going to take a couple of those and make it like that. So now here, instead of having these positive edges, you're going to have the change here at the positive edge of the clock. Now I'm going to have the changes here. So you need to see here, the changes are much slower so we can see it by eyes. So we want to make it from 50 megahertz to just 100 hertz, okay? So now I want to see the factor that we're going to be using. It's going to be the 50 megahertz over the 10 hertz, okay? And mega is 10 to the power of 6. So we're going to have 15 times 10 to the power of 6 over 10, over 100 here. So that is going to give you 5 times 10 to the power of 5, okay? Now that is the factor of this whole thing here. But given in your clock divider, we have an integer number that's called half. And what we mean by the word half here is that we're talking about half of this signal here. Okay, so I have to divide. So the half is just going to be that factor that I come up with divided by 2. So that's going to be 2.5 times 10 to the power of 5. Or in other words, it's going to be 25, 1, 2, 3, 4. Okay. So that is the value of the half that I will be using. Now you're not going to write that down in your clock divider. You're just going to keep the word half as your as an integer generic. And we're going to plug into the input output file the value of the half, what it is. Okay. So that is for your clock divider. So that's part number 1. That you need to know from this part here, and why are we using the clock divider and how are we using it. So we're using it to slow down the frequency of your original board, which is 50 megahertz. Okay, now number 2, you're going to be designing, of course, this BCD to 7 segment display. I'm not going to talk about that because you've done it in previous lab. Now what we're looking for displaying, okay, on 6, 7 segments displays here. Okay, I want to display the seconds all the way to 99, and here here is the part of seconds. So this is part of seconds, and here is the seconds, and here is the minutes. Okay, so also all the way to 59. So we know that for this one, particularly for this one and this one, I need to count all the way to 5, okay? And once I count to 5, I need to just reset it back to 0 and just start to count again, 0, 1, 2, 3, 4, 5, all the way to 59, okay? So that's gonna be my maximum number that I will be using there, okay? So let's see for the third logic file that we need to create in the lab. Number 1, I need to start counting from here, right? So I will count here. My count is going to start 0, 1, 2, 3, 4, all the way to 99. Once it reaches 99, I need to send like a flag. I'm just going to call it a flag. I need to send a flag to this second to say, now you can start counting. Then the second part is going to stop counting 0, 1, 2, 3, all the way to 59. Once it reached 59, now I can start to count the minutes. So I need another flag here, okay, to tell me that the minutes can start counting. So actually, this is my clock, okay, that I'm going to be creating from the clock divider, okay, which is the 100 Hertz. So this is going to be my clock. I can call it my clock, okay, not the clock of the FPGA. Now I reduced it. So the input here is going to be my clock. Now, when I reach the numbering here from 0 to 9, okay, so I'm going to have here a counter that's going to count from 0 all the way to 9. Once it reaches a 9, I want to send a flag to the next 7 segment. Okay, also I want to send a flag here to the next 7 segment to say, okay, you can start counting from 0 all the way to 9. Okay, and also this one is going to be continuing again from 0 to 9. So every time this reaches 9, it will send a flag here to the next one to start counting from 0 to 9 and so on. Once I reach 9, 9, okay, so once I reach here, both of them are 9, 9, I'm going to be sending a flag, okay, to the second to start counting. Now I'm going to do the same thing here. It will start to count, and once it reaches the number 9, it will send a flag out. Okay, it will send a flag to the next 7 segment display. Now in this 7 segment display, I need to use what we call a check digit. Okay, for that check digit, let me just call it like this, check digit. If the check digit is equal to 1, it means that I will count to 5 only. And if the check digit is equal to 0, it means I continue to count all the way to 9. Okay, so I will be using the check digit in this one here for these two. I'll be using the check digit. If the check digit is equal to 1, it tells me that I need to count all the way only to 5. And if the check digit is equal to 0, it means that I can continue counting all the way to 9. And I will do the same thing here, okay, for that check digit. Now, I know that it's still not clear how we're going to do this, but let's move on to the next page and I will show you to be more clear. So for my code, I'm going to call the BCD lock. Okay, that's going to be my new VHDL code, VHD. Okay. Now for that one, I will make sure that my inputs, I'm going to have an enable. Okay. Enable this is going to allow to start counting. Okay. So once you hit you make that switch goes to 1, it means that you're going to be starting counting. I'm going to have another input that's called check digit. Okay. And that will be checking if I count to 5 or 9. Okay. Also, I'm going to have my clock. Okay. So that's going to be the clock entry for each 7 segment. What do we mean by that? Now let me go back to the first page here. So my first clock here is the one that I originally created from the clock divider. Now every flag is considered to be the clock for the next 7 segments. So this flag here is the clock for this one. This flag here is the clock for that one. This flag here is the clock for this one, and so on. So each one of them is going to have their own clock that is coming from the previous state. So I'm just going to call it here my clock. And I have my flag out. Okay, so each one is going to have an entry as a clock and a flag as an output. So this is the output indicating complete counting and resetting. So you should be resetting and counting back again, okay? Or move to the next 7 segment, or move to the next segment, 7 segment display. Okay. And also I'm going to have my count, which is actually going to show you the number. you're counting. You're counting, this is your output, the number that you are counting. So that's going to be your output. It should be a Victor, of course. So that's showing you the number that you're counting. Okay, so let's see how are we going to be working with this. Let me just get this down with my 7 segment displays here. So let me just put them here again. Okay. So what you're going to be doing is that number one in the BCD lock code, the logic file, you're going to be saying that if your enable is equal to 0, of course, I'm not going to do it here with, I'm just putting like a pseudo. If enable is equal to 0, then your out count or my count is just going to show a 0. Okay, it's just going to show 0 everywhere. Else, if a clock event happen, and clock is equal to 1, then I will start to check the different cases, okay, for my count. Okay, so when my count, when my count is 0, 0, 0, 0, okay, and I have a clock cycle, that's going to move to my new count, my output count, okay. The output count, or let me call this one just count, okay. And this is going to be my count. So this is your output one. So my count is going to be what? It's just going to be 0, 0, 0, 1. Okay. And now when your count is 0, 0, 0, 1, your new count is going to be 0, 0, 2. So when you're at 1, it's going to go to 2. When you're 2, it's going to go to 3, and so on. Okay. That is, you're describing this for every single segment. Okay. We know that we're going to go all the way to 9 for every single segment. Now, what we want to do here is that when I'm saying that my count is equal to 1, okay, so for example, here I'm showing the number 0. And then when I am at 0, I'm going to go to 1. When I'm on 1, I'm going to go to 2, and so on. Every time I'm doing these counts, I need to say that my flag is equal to 0. It's not equal to 1 yet. The flag that's going to stimulate this one to start counting. So my flag here is going to be 0. Also, my flag here is going to be 0. Okay, and then I keep counting until I reach the number 5. So once I reach the number 5, okay, now I'm going to do an F statement. So I'm going to say that if my check digit, okay, is equal to 1, then my count is going to be going back to 0. Okay, and else my count will just move forward to 6. So it will just behave regularly. Okay, and you end your F. And of course, probably, okay, let me just put it down here so I can make it clear. So F, my check digit, okay, is equal to 1. That means that my count is going to go back to 0. And also my flag is going to equal 1 now, which means that my flag is going to come out as a 1, telling you that you need to start reinitiating your count back again. Else your count, my count, is just going to be the regular number. So from 5 is just going to move to 6, and the flag is just going to stay as 0. Okay. And of course you end your F there. So that's when it's equal to 5, then you're going to do the 6, 7, 8 all the way until you reach the 9. So the 9 is a special case. We're going to say that when your count is equal to 9, okay, then at that point, I will be checking. Sorry, at that, I will say that my count is going to go back to 0. Oops, it's going to go back to 0, and my flag is going to equal 1. Okay, so which means that if it only make it to 5, it's just going to have the flag here is equal to 1, and it's going to stop counting at that point and move to the next 7 segment. If this one didn't satisfy, it means that it's just going to continue counting until it reaches the number 9 and then give you the flag equal to 1. Okay. So for example, for this one here, my check digit is going to be 0. For this one here, my check digit value, I'm going to make it 0. For this one, I'm going to make my check digit equal to 0. Here also, I'm going to make my check digit equal to 0. Here, I'm going to make my check digit equal to 1. The same thing here, so that it can count only all the way to 5. Okay, so either it reaches 9, it will give you a flag to start counting in the next one, or it gives you, or it ends up to 5, and again, it will start initiating the counting in the next 7 segment display. Okay, so this is like the part that you're going to have in your architecture of the BCD lock, of the logic file. Now let's move on to the input-output file. For the input-output file, okay, you're going to be, of course, in the components, of course, in the entity, you're just going to put the entity that we're used to put in the input-output file. Now, in your input-output file here, you're going to be calling the clock divider. Okay. So we're just going to call this your first processes. Okay. And you're going to be port map. So before you do the port map, you're going to have the word generic. Okay. And you're going to plug in the number here. So this is where you plug in the number. Okay. So that is the factor that I will take to the clock divider to slow down the clock. Okay. And then you say port map. You're going to have your clock 50 megahertz, which is the original clock of the FPGA, and then your clock that you're going to come up with, the slow clock, which is the 100 hertz. Okay. Now for your next processes, you're going to use the BCD lock. Okay. Now the BCD lock will have multiple inputs. It will have the enable. So maybe that's going to be your switch number 9. So whenever you make that switch equal to 1, it will start counting. And let me see what we have here. Okay, you're going to have your check digit. Okay, your check digit. So now for the first, I'm going to call this BCD, the process 2. Okay, it's going to be for this one. So for the check digit here, I just want to, instead of putting the word check digit, I'm just going to plug in the number 0. So whenever it goes to the BCD lock code, okay, it will check it here. It will check the digit here. If it's equal to 1, it means that I stop counting at 5. If it's not, I will continue counting all the way to 9. So I want to count all the way to 9 here. So I will make sure that my check digit is equal to 0. And then my clock is going to be the clock that came up from here. So it's going to be my clock. Okay. And then I will have an output, which is a flag. Okay. I can call it a flag out. And of course, I'm going to have my count. Okay. The number that's going to show up. Of course, the count here is going to be your input to the BCD to 7 segment display. I don't know what did you call it, but that's going to be like your third processes that I'm going to take my count as my input, okay, and then I'm gonna show up the at your hex, at your first hex here. This is hex 0, for example. This is your hex 0, okay, and this is your hex 1, and so on. So you're gonna show your output here on the hex 0. So it's based on how you created your BCD to 7 segment display. So this is not like fix it. It really depends on how did you code it in the last lab. Now you're going to move on to the next 7 segment display, this one here. Okay. and you're going to be calling again the BCD lock. Now you're going to put again the SIM switch, which is the enable. You're going to put the check digit as equal to 0. Now your clock is going to be the flag from the previous one. So it's going to be this flag out. Okay, so you should give it names. So you can call this flag 1, for example. So I'm going to call it flag 1. That's going to be my new clock. And then flag 2 is going to be my new flag that's going to come out, okay, as an output. And then my count, okay, whatever the count is going to come up, the number, okay. And then you're going to take that count for U4. You're going to do the BCD to 7 segment display. You're going to take your count, okay, and display it on hex 1, for example. Okay, you do the same thing for the third one here. Okay, so these are for the part of second. This is going to be for the second. Again, you have a flag that's coming in. So for U5, I'm going to say BCD lock. Okay, again, my switch 9 is my enable. Again, I need my check digit to be 0. Now the input here is going to be the flag 2 because that's my clock. And I'm going to output a flag 3. And again, I'm going to be counting. The same thing for the BCD to 7 segment. I'm not going to do that one. BCD to 7 segment. Okay. Now for this one that's going to show up 5, I'm going to call this, if this is process 6, I'm going to call this process 7. So BCD lock, I'm going to have switch 9 again as my enable. Now my check digit is going to equal to 1. And then my input clock is going to be the flag 3, and I will output flag 4, and then I have my count. And you keep going until you finish all of the 6 hex representations for your clock. Okay, so this is just briefly how you're going to be thinking about it. So for the BCD lock logic file, okay, for the BCD logic file, you're going to have inputs your enable. You're going to have the check digit. Okay, you're going to have, you call my clock. If you want to call it like that, you're going to have a flag out. Okay, so my clock is always the flag in that's coming from your previous state, and then the flag out, and then my BCD count. Let's say my BCD count, or whatever you want to call it. So these are the major inputs. Of course, in your architecture, there's going to be some signals that you need to declare and so on. So you're going to be figuring that out, but at least now you have the big idea of how are you going to be using this and moving from one 7 segment display to the other, knowing that each one of them is going to output a flag, and that flag is working as a clock to the next 7 segment. So here, this is the clocks. Okay, all of these are the clocks, and these are the outputs, the output flags. Okay, so the output flag here is just going to be the clock in the next 7 segment. Okay, so I hope that will help you out with your clock design. Thank you.